So today I'm going to talk about graphing data. Before we start talking about the data, we have to talk about what kind of topics. So I'm going to start with some examples. So maybe we're interested in collecting some data on the different preferences that people have on types of pets, or how many they like to have. Or maybe we're interested in talking about like the types of sports people like to play, or how often they like to play them. Or maybe we're interested in more numeric data, such as like the amount of rainfall that falls in a particular area over the span of a certain amount of time. Or maybe we're just interested in the heights and how they differ among different groups. So once you figure out your topic, we can collect our data. So when we get our data, it's a bunch of numbers, we don't really know what to do with it. So how do we make sense of this? Well, one way we can make sense of what our data is telling us is we can make a graph. So one of these types of graphs we can use is a bar graph. In a bar graph, you start with your data and you break it into different categories that represent your bars. That represents the x-axis of your bar graph. And on your y-axis, you have your frequency. So in our example on this picture, we have the average monthly rainfall for a particular area, and they broke the data into the months of the year. And each bar graph, it represents the amount of rainfall that fell for each particular month. So as we can see from this bar graph, we can see that the highest amount of rainfall fell in the month of May. So with the bar graph, it's nice that you can be able to see the differences among your different categories, and you can see which ones are higher, which ones are lower, and how they compare to the overall group. And here's another example of a different type of bar graph that has, instead of the side being a particular value, as the other one was rainfall, this one has just the frequency or number of people that fall within each category. So this one has, the categories are the different types of pets that people have. And this one you can see that the greatest amount of people had cats as pets, and the lowest amount of people had rabbits. So this is nice because you can also see which ones are more popular, what is more of a preference, so you can see more, learn more about your data overall. And if you're not really interested into a bar graph, you could also use a dot plot, which is basically doing the same thing. Instead of having a y-axis though, you just have a number of dots representing the frequency that each category has. This one again has the different types of pets that people have, and the greatest amount were in the cats again. So the data set shows that the most people prefer to have cats as pets over all the other types of animals.
So in your rainfall, there was an obvious ordering to the bottom because you just go January through December.
Yep.
Is there a preferred ordering when there's no it's not like dogs are bigger than like is there a preferred, should you order it so that the highest frequency thing is always all the way to the left and kind of steps down, or should you do it
Kind of doesn't really matter. I mean, it's more of a preference. So if you wanted to do that, you could. You can make the higher graphs or the higher bars on one side, whereas the shorter ones are on the right. It's kind of just doesn't really matter because it's not really any particular order on the bottom. It's just however you wanted to put it on there.
Okay.
And then another type of graph we could use that's similar to a bar graph is a histogram. Instead of using categories though, you end up using an interval, and each bar represents not a category but a specific sub-interval of the entire larger interval that you're using. So the example on the left, you have the number of pets that people had, and you can see that most people had between 1 and 2 pets, and there was the least amount in 5 to 6, and it says there was none. And it's also important to notice, even if you have an interval that has nothing represented in it, you must still put that in to make sure that your graph is complete. You can also use a histogram to compare more than one group at once. As you can see on the graph on the right, we are comparing the heights of males and females, and the green bars represent the height for males, and the orange bars represent the height for females. And as you can see, the green bars are slightly over to the right more than the orange bars, demonstrating that height of males is slightly larger than the height of females overall. Also with a histogram, you can notice that your graph will show whether or not you have a normal distribution, as you can see from the lines that are drawn over each side of the graph, and which is important for when you're doing your data. You would really want a normal distribution since it's easier to interpret when you're doing your statistical analyses later. Also with the histogram, you also notice that the different subintervals include all of the values within that interval. So with the number of pets, you can have between 1 and 2. You can have 1.5 pets. But with the height example, you could have between 1.6 and 1.7. You could have 1.65 in the middle of that graph. So each bar doesn't necessarily equal one particular value. It could be any of the values between the two intervals. Also, another type of graph we could use is a pie chart. A pie chart is similar to a bar graph in that it uses categories of your data broken into different categories. And when you are making the pie chart, you use each different category represents one pie piece of the entire whole. And how to find each of those pie pieces, you take the category and you find out what percentage or proportion it uses of the entire data set. So in this example, I have the different types of sports that people like to play, and you can see that the largest section of the pie is the 30% piece that is blue that corresponds to soccer, so that there's 30% of your data is represented by people that prefer to play soccer over all other sports. Also with a pie chart, you also must notice that you cannot have any more or less than 100%. It has to be exactly equal to 100% of the entire data, because you can't have less or more than that. You have to represent everything. So to demonstrate how this is important, I have a real-world example. This is a pie chart that was used by Fox News a couple years ago when they were doing the presidential election, and they tried to make a graph of the different people that were supported by the overall. So you can see that it equals over almost 200%. So that's not how you make a pie chart. So we don't want to be like Fox News and use misleading graphs. So to conclude, why are we even making the graphs? There's two reasons why you'd want to use graphs. The first is that it's easier to communicate your results of your overall data to others that don't maybe understand all of your statistical analyses that you might be using to analyze your data. Since you can show a graph to any normal person and they can see the differences between the different graphs, or like as an example with the bar graph, you can see the different heights, so you can see that one has got more than the other. And the second reason is that if you use a graph, you can maybe be able to look at your data and see which areas are more prominent than others, and that can show you what you might be more interested in investigating for future research.